Thank you everyone for joining this session. Quick introduction about myself. My name is Sunil Ranganathan. I'm from Bangalore. I've been with Credence for about 2.5 years now, and an overall experience of about close to 19 years building data and AI ML based solutions across multiple clients. Before we move forward, I'd also just quickly like to talk about Credence for a minute. Credence is a services provider in the space of AI ML solutions, and especially in enabling last mile adoption of AI ML solutions, right? We work with 7 of the 10 top retailers in the world and 8 out of the 10 top CPG companies in the world. We've been named Retail CPG Partner of the Year by Databricks for the last 2 years. Yeah. So with that being said, I'll just quickly move forward into this session where we talk about how we've scaled demand forecasting as a solution across markets for one of our customers, right? Quickly go through the agenda. I'll walk you all through what was the use case, what were some of the complexities, give you a quick overview of that, then deep dive into how we approached the solution, what did the architecture look like, what were all the changes and modifications we made to make sure that we were able to scale across the volume and across the complexities that we saw. Also want to touch a bit on how we set up monitoring, because whenever you are going to be scaling ML models across a large set of markets, you do want to make sure you're monitoring these models in production so that if there are any anomalies, if there are any issues, you can be proactively informed rather than much later. And then lastly, just walk you through some of the key challenges and learnings that we've had through the entire process, and how we look to solve some of these things, and save about 10 minutes in the end for questions. Right? Before we start, a quick overview of the customer. Right? Our customer is one of the largest CPG companies in the world, and they already had a demand forecasting solution that they had built out. Right? The solution in this case was built by a different vendor, and the problem that they were facing was the solution that they had was market specific. They had one set of algorithms per each market, and these models, the way they were set up, were not very modular. They lacked any kind of reusability. They were very unorganized. A lot of the times we had data scientists sitting and executing these models in a development environment, right? And it took a lot of the steps were manual. You had manual files coming in. You had these data scientists sitting and running step by step, running manual validations, manual data validations. So the entire process for certain markets took 2 to 3 days, and they wanted to do this weekly. So a lot of the time, just the weekly refresh took about 2 to 3 days in certain markets. In certain markets where they had a bi-weekly or a monthly process, it used to take them about a week or even more than that, right? So an absolute lack of automation, no standardized monitoring in place. That's the situation that we were in when we started taking this up, right? So what all did we do? We started with simple refactoring of the models, and I'll walk you through that in detail, where we look to parameterize the models, modularize the models, ensure that there is a lot more reusability. We took a lot of time to redesign the ML approach in terms of, what's the data engineering pipeline, the feature engineering pipeline, the actual model build, and then going into how can we automate data validation, and then finally go into monitoring, right? We automated their entire CI/CD process, so now when you're having multiple people work on that, how do you merge their changes? How do you move from one environment to the other environment? We set up a DR for them as well as part of their audit. One of their requirements was to make sure that they had a disaster recovery environment set up as well. So we did that. And some of the benefits that we've seen, so we are now live in about 15 markets right now. The benefits that they saw was, the reduction in weekly execution time, right? What used to take them 2 to 3 days is now about 5 to 6 hours. About 80% of the entire solution is automated. You still have minor places where you do have some kind of manual interventions, but otherwise, most of that particular solution across each of the markets is automated. You were able to integrate CRs, change requests into these models much faster because you've now simplified the entire architecture. You've made it modular. You've made it standardized. integrating newer CRs into the existing code becomes so much simpler. You just have to do it in one place rather than doing it in 10 different places, right? So that's the overall context. And how did we go about this, right? We spent about, you can look at this as breaking it up into 3 phases, right? Phase 1 was what I spoke about, where we actually went and did all of that work in terms of industrializing the entire code, right? And the benefits for that particular phase is pretty obvious, right? You could see reduction in runtimes, you could see automated systems. The number of scripts also reduced by about 40%, right? In certain markets, for example, in one of the markets, they had 150 scripts across different, to complete end-to-end process. That 150 scripts was now reduced to about close to about 95 to 100 scripts for that particular market, right? And that was the case where it was so unorganized. You also had the reverse example, right? In certain markets which are very simple, you had barely about 7 to 10 scripts, but they were huge scripts. There was not broken up into specific sets. So in that case, there was a slight increase in the number of scripts. But overall, when we saw across all of the 15 markets when we went live, we saw about 40% reduction in the scripts. And that obviously improves maintainability, right? Because you have fewer scripts to maintain, it becomes easier to look at it. But moving to production and starting to execute it on a week-to-week basis is just one part, right? You need to make sure that you have a team that's available to monitor these models in production on a regular basis, right? The way they were doing it before was they had their existing data scientists who built it out, were now looking to run it manually and monitoring the models in production. When we went live across all of those 15 markets, we just reduced that number by more than half, right? So across all of the 15 markets, we don't even have about, it's not even a 1:1 ratio, it's about 2:1 ratio, right? And the number of people supporting those markets, supporting these models reduced. And what do they look at? They look at tracking, whether the refresh is completed on time, whether the model accuracy is being maintained, is there any drop in model accuracy, is there a change in model bias? We're also monitoring cloud costs, right? Is there any sudden increase in cloud costs? So all of that is being maintained by our ongoing support team. And then lastly, obviously, there's a separate team that looks at how do you manage change requests. It's a live solution. Things change, businesses change, hierarchies will change, your requests will come in. You continuously want to go ahead and improve those models. You want to work on those models, right? And that's how we had a separate team to look at how we can track and manage change requests. Moving into architecture, right? What's the kind of data that we had in each of these demand forecasting solutions? We had obviously sell-in and sell-out data, which looked at data coming in from their primary and secondary sales. You had product master, obviously one of the most important aspects when you're looking at demand forecasting. You had customer master, and within customer master and product master, you had different product hierarchies as well, right? And across different markets, you would predict forecasts at different levels, and it was very market specific. In certain markets, you would predict it at a very, very granular level, and in certain markets, you would probably not predict at that granular level. In fact, even in a particular market, for a certain category, you would go right down to the SKU and location level, whereas in certain categories, you'll probably go up to the subcategory level. And most of this data was coming into 2 sets of data lakes that the customer had. They call this a universal data lake and a business data lake. The universal data lake is when it's just an exact copy of the source, whereas the business data lake is where they had some kind of transformations coming in and they had business context added in there. So for example, the product master, the customer master, all of that came through the business data lake, whereas a lot of these raw input sales files came in through the universal data lake. All of the code was written in Python PySpark, and it was now saved and versioned within Azure DevOps. That's the repository that we were using. And the outputs were going to multiple systems. They were written back to your data lakes, but they were also going down to your downstream trade promotion systems, to their planning systems, for how it is going to be absorbed by the demand planners, and in terms of ordering, making orders, and how they want to use those forecasts, right? And they obviously had a couple of dashboards that were built out of all of these forecasts in terms of how they can look at these forecasts at a category level, at a region level. They even had demand segments, high volume segments, low volume segments. So you had a Power BI dashboard that could consume the output of all of these forecasts. So I'll take a quick pause here and describe how each market looked like, right? What was the complexity involved in each of those markets? For each market, you had sort of a general trade and a modern trade. Modern trade is typically your most of the advanced countries have only modern trade, but in certain markets like Indonesia, you also had a lot of small mom and pop stores where you had all of these items selling, and that's where you had a large proportion of general trade. So a lot of the models were now broken up into two categories. You had one set of models for predicting forecasts at a modern trade and one set of models for predicting forecasts at a general trade. And again, within each model or across multiple markets, you had various types of forecasts, right? You had what we called a generation 2 or baseline forecasts only, which did not take into account any kind of impact from promotions, right? It was just based on raw demand. In certain advanced markets, you had Gen 3 forecasts where you had total forecasts that took into account how promotions played a role in terms of increasing the baseline forecast and give you a total forecast. It also included, in certain cases, cannibalization effects. So certain promotions are going to be cannibalizing another product, so how can you take that into account into your forecast as well? So both of that used to come in your Gen 3 forecast. In Gen 4, which is a couple of markets, you also had price elasticity play. So how are you looking at price elasticity changing in prices affecting demand as well, right? So all of those were part of the complexities involved in each of these markets, correct? And in terms of hierarchies, two primary hierarchies in terms of customer hierarchy and product hierarchy, right? The customer hierarchy typically went up to 10 to 12 levels, depending if you're going down. If you're getting sellout data, that means you're getting secondary sales as well, it'll go up to 12 levels, whereas a product category it was anywhere between 4 to 6 layers. And for each of these markets, you could have different combinations. So in effect, across the 14 to 15 markets that we had 250,000 combinations of forecasts, right? At a G10 level, at an account planning group level. So if you sum up all of the permutation combinations across the 14 markets, to give you a level of complexity, we had approximately 250,000 levels. And each of these and we had to publish forecasts for each of these 250,000 levels across 2 years. So we used to read in 3 years of data and publish forecasts for 2 years. Now coming to exactly what we did as part of this industrialization, right? Like I said, when we started there was a lot of code that was, the initial models were all written at a category level. So you had one model for say, personal care, you had one model for ice creams, you had another model for home care. And each of these models were written by different data scientists, and they had their own engineering pipelines, they had their own data pipelines. None of the best practices were followed. So when we started, what we saw was there was a huge scope for modularizing the entire set of codes, and you could reuse a lot of those codes that were already written. So the first step that we did was first look at one particular market and create an entire design in terms of what are all the data sources that we are looking at. Now, once we have all of these data sources, what are the key attributes within each of these data sources that we need for our models? And then we start ingesting those models, excuse me. We start ingesting the data for all of those attributes, do your feature engineering. And again, the feature engineering again would be centralized so that you don't have every category model does not repeat each of those feature engineering again and again. And this, believe it or not, makes a huge advantage when you're actually looking at CRs, right? When you now parameterize your models, your entire pipeline, when you now modularize them, any change requests that come in when you want to change some of those feature definitions or you want to add new stuff, you need to add it in just one place. You don't need to go and add it in 10 different places. It just simplifies maintainability, and one of the biggest benefits that we got was improve adoption of change requests. Correct. The other thing that we did was we set up versioning. We integrated with the Azure DevOps. And we started the entire CI/CD process. And then in the next slide, I'll show you how that entire process worked like, right? And we instituted standardized logging and monitoring. So a lot of the times, when the data scientists were running their models, they used to have print statements after every step to see and review data before they executed the next steps. So again, what we did was standardize the logging, and wherever it was needed, we saved even intermediate results as well. So that in case of any errors or in case of any questions raised by demand planners, it's always possible to go back and look at how the intermediate steps have flown in, and then you can start debugging it much better. Thank you so much. We also did a lot of work on model monitoring, right? And I'll talk about this in one of the other slides, where we looked at comprehensive model monitoring in terms of identifying the data quality that is coming in, identifying your data drift in terms of how your data has changed from previous weeks, in terms of looking at model accuracy metrics, maybe your model MAPE scores, your bias scores. And we also looked at how we want to look at explainability. So we did a lot of work in terms of breaking down each of the forecasts by steps. You first have your baseline forecast, then you have your promotions come in, then you have your total forecast. And a lot of the times you also used to get manual adjustments that come in from demand planners, right? So we used to then get adjusted forecasts that come at the other steps. So one of the biggest learnings that we had implemented was make sure that we have a very, very clear explainability of forecasts so that it becomes easier for demand planners to understand and even debug where something is going right or something is going wrong. Yeah, this is a quick example of what are all the aspects that we looked at before starting any market, correct? When we started any market, we did a proper assessment of the codes within each particular market in terms of how modular they are. Do they have a standardized methodology for tracking, for logging? Do they have all of their pipelines automated? Do they have unit testing set up? Do they have a DevOps environment set up? And when we did this, when we did this for the first market, it took us close to about 8 to 10 weeks to do this. But once we've done this initial work of setting up the standard pipeline and the standard ML design, onboarding subsequent markets to this particular design became so much simpler. Right, so when in this current example, when we looked at the first market, we took to about 8 weeks for the first market, and after that, every subsequent newer market was done in about 3 to 4 weeks. You could onboard them, set them up in production, and start running them on a weekly basis, right? In a very rare case, when you're getting a completely different market, a lot of these markets were very regional. So for example, Switzerland, Austria, Germany were very, very similar. But when you get in Indonesia, which is a completely different generation of a forecast, that had a little bit more work that needs to be done in order to make it ready for production, right? And ready for that particular scale. And this slide talks about the ways of working, right? So initially, like I said, you had each of the data scientists used to work in their own separate folders, right? Build out their codes for their particular models. If I'm working on say, ice cream category, another person is working on a separate category. Each one would create models in their own personal folders, and they would run it independently, or they would combine that into one particular code and run that independently. There was no separate production environment that they used to use, or even if they did, they did that in the same manner. They used to take the same codes into production, run them step by step by step. But when we came in, what we did was we then created folders for every market, right? Within the forecasting solution, we had market-based folders. And each of the markets, you had a standardized template that you could use and onboard all of these codes. After that, we then set up standardized CI/CD pipelines, and when there were any changes being made to that particular code, you could have a feature branch that is then merged. You could have a pull request raised, typical CI/CD process, right? Merge it into the main branch, then goes through an entire review. We had SonarQube testing. We had standardized code review output as well. And when that passed, it used to move into UAT phase, right? And UAT was very, very important as part of the entire industrialization process, right? We ran typically a 4-week UAT process where we used to run manual forecasts the way the existing data scientists used to do it, week on week. And we used to run our modularized templatized code. And only if there was absolutely no deviation or variation between the two sets of codes, we would say, yes, I think we've done a good job now, we can then go ahead to production. But we used to run that in a production, so it was sort of a parallel run to make sure that our entire process is not just streamlined it, but it's also making sure you're having the same quality of forecast as what it was before, right? And this just, and then obviously you move to production, right? And once you've got a sign off, you've got a checklist covered saying, have you done your market communication? Have you set up? So you also set up the entire service now, right? To make sure that now any errors that are raised or any bugs that are coming up with a ticket, because the most important thing when you're dealing with scale is you want to make sure it's standardized, and only then you can scale across markets. And one of the big aspects there was you don't want any issues coming up via email. You want them to make sure that they're now raising it in a standardized process through a ServiceNow or a ticketing system. Yeah, coming to monitoring, this is where we did quite a bit of work. And when we are now looking at monitoring, we started looking at first looking at what the input data quality was looking at. And there we looked at uniqueness in terms of now you're getting sales data, you're getting promotion data. What is your level of uniqueness? Are there any records which are coming at the same level with different values? So this was a quick win, and we did face some issues, and that's why this was some of the things that we instituted before, right? Validity. Again, data type errors were huge, were abundant, and especially when you had manual demand planners send up product hierarchy updates or customer updates, data types used to always be a problem. So we set up a very, very clear check for making sure that your data types that are coming up in your input data was was as per what the requirement was, and if not, you would raise the flag much before rather than realizing it much later on. Timeliness was another important thing, right? We had certain hierarchy updates that were supposed to come every month, and then now we had a dashboard. Let me just quickly show you this dashboard, right? This dashboard shows you how we looked at completeness, how we looked at uniqueness, how we looked at measuring when that particular file or the table was last updated. So now this gives you saying if you have any issues, saying that, this is not matching with the correct hierarchy. Why? Oh, you know what, this product hierarchy file was last updated only on 2 months back, whereas now you've received a new file which you've not given it to us. So this made it very easy for us to understand where something is broken and how we can make sure that you're able to debug data quality issues better. Right. Then coming in terms of model accuracy, we used to look at MAPE scores, we used to look at model bias. We also looked at trends in these scores. Right. The most important thing in demand forecasting is you don't want high fluctuations in accuracy or bias. As long as it's steady, as long as it's maintaining that curve and trend, you're able to rely on those forecasts much better. And the other thing that we wanted to compare was, for every market, you had a set of demand planners, right? And those demand planners used to create their own set of forecasts. And how we compare our accuracy of our forecast with that of the demand planners' forecast accuracy was a key indicator of how successful this program was, right? And that's what enabled us to show that over time, our forecasts are actually now better off, and the number of manual touches or the manual interventions that demand planners make to change these forecasts were reduced, right? We also looked at anomalies, right, in terms of if there's sudden spike in sales, a sudden spike that's not noticed before, or you can look at seasonality in terms of did we see the sudden spike even last year or the year before that as well. So those were also some of the things that we instituted as part of our entire monitoring process, right? And last but not the least is explainability and bias. I spoke about making sure that we have a step-by-step process to track how these forecasts are calculated. Like I said, you have your initial baseline forecast, you have your promotions coming in, then you have your total forecast, then you have your demand planners coming with manual adjustments, and then you have your adjust with forecast. So at any point in time, if there is a sudden deviation that comes in from some of the demand planners, it's very easy to understand where in that entire chain the forecasts have shot up or they've gone down. So if you see that the baseline forecasts are accurate, your total forecasts are accurate, but you know what, because of this manual adjustment that's come in from some of these demand planners, that's why your final adjusted forecast has changed. It becomes, the explainability of the forecast becomes so much more simpler, right? We also had feature importance baked in. So for example, for this particular forecast, which are the 5 or 6 attributes, which are the 5 or 6 features that cause this particular forecast to go up or go down? And that was also something that we had within our monitoring metrics, right? Yeah, this was some of the examples of the dashboards. I already walked you through it. A lot of the times we looked at forecasts at a category level, but you could also go and drill down at a further level, right? Most of the demand planners used to look at accuracy at a category level, and if there is certain deviation in that particular accuracy, you can then deep dive into, a GTIN and a location level to see where the problem is, or where are the top 10 keys where your forecasts are up or down, and then deep dive into that a little bit further. We also put in a very, very stringent set of guardrails. I already spoke about your category level forecast, right? So we typically used to compare forecasts for the current week with the forecast within the last week. And if there were any changes beyond what a threshold, and this threshold is now at about 10%, right? Then it would send out an alert saying, there's a sudden spike or drop in your forecast. Please go look at it and see what's the problem there. We also used to look at inbound and outbound promotions, right? We received separate set of promotions that go as input to our entire planning process. And if that set of promotions are applied, so we want to make sure that there's a count of, if you've now received about 150 promotions across, say, 200K products, is your output forecast also accounting for the same set of same set of promotions, and do you have so many related promotion-related forecasts? Yes or no? And that becomes a very important check to make sure that you're not dropping any promotions as part of the entire process. We also had a threshold for zero forecast. A lot of the time, even though you have zero sales, typically a model should not, very rarely you will have a model predict zero forecast. You'll have some sort of a lower threshold, but we want to make sure that your zero forecasts are below a certain threshold, and if that particular threshold spikes up, you can know that there's some kind of issues there. And similar to that, you have anomalous forecasts, right? If you have sudden spikes or sudden drops compared to earlier weeks, again, that should not be within a certain threshold. You should not go beyond a certain threshold, and that's how we started monitoring some of these things. I'll go into some of the nitty-gritties here in terms of what makes this so complex, right? And why this is so challenging at times, right? Aggregation levels, right? Like I said, we have 250,000 combinations of product and customer hierarchy. And across different markets, across different categories, there was an expectation to send outputs of these forecasts at different aggregation levels. So you had to maintain separate mapping files where you now look at, for this product category, for this particular market, you maintain forecasts at this level. And for this market, at this category, you maintain it at this level, right? Those were some of the challenges that you had in terms of volume. But a lot of the other issues that did come up was, transitions in terms of SKU changes, right? What used to be SKU A has now become SKU B. How do you handle those particular changes in your forecast? How do you accommodate? So you now have a lookup table that you need to maintain as part of the process. And that needs to come in as a week-on-week process. So every week or every 2 weeks or every month, we now received the list of SKUs that have been changed or transformed. And you have to account for that within your entire process so that it does not become a manual process, because this is the norm, right? Most companies will have rebranding or SKU ID changes. So you need to make sure that you account for that, right? Similarly, delisting of SKUs, right? Certain SKUs are no longer valid, and now you need to make sure you don't need to provide forecasts with that. The challenge here is when you're especially integrating with multiple systems and you're integrating with downstream systems, System A will know that this SKU is delisted, but System B will not know that this SKU is delisted, right? So in those cases, it becomes really important to make sure that you're capturing very, very clearly that these are your delisted SKUs, and if they are comparing numbers across two different systems in terms of forecasts or actuals, you're now able to understand that the forecasts are not generated here, because when you roll it up at a category level, that's where the difference starts to come in.